Welcome to the CompTIA Network Plus N10 This is Chapter 5, Installing a Physical Network. Let's look at the objectives for this chapter. 1.2. Explain the characteristics of network topologies and network types. 1.3. Summarize the types of cables and connectors and explain which is the appropriate type for a solution. 3.2. Explain the purpose of organizational documents and policies. 3.3. Explain high availability and disaster recovery concepts and summarize which is the best solution. Or 5.2. Given a scenario, troubleshoot common cable connectivity issues and select the appropriate tools. Okay, so on the left hand here, we see a simple network. Well, not all networks look like that. They're not always orderly. In a real-world scenario, you might have different segments of different kinds of computers and equipment, and maybe even segments of computers that should be together. So this looks more real-world in different segments of a network. So it can provide different challenges on how to wire a map and lay out a network and get the work area and the telecoms wired correctly and everything that you need to do. Okay, so earlier I was talking about the telecom room or the telecommunications room. So all of your cables will run preferably horizontally up and over and go into the work area. So when it's finished, it'll look something like this, and that way we have 4 different desks or 4 different cubicles that have the same layout. Okay, so what do you see in the different pictures here for these types of cables? Well, maybe the one on the left you're a bit more familiar with. The one on the right, I wasn't quite sure if it was real or if it was just like a joke, but I learned myself about 25 pair and even 100 pair cables that were used a long time ago in telecommunication rooms, where they would just have 1 or 2 cables and they would wire all these telephones with it. Nowadays, we wire each computer for each UTP, and then it's a bit more redundant that way. Okay, so let's move on to racks. Rack equipment is 19 inches wide, and they measure it in what's called a U, or some people refer to it as a unit. So this would be 1U and 1U, 1U, 1U. So we can measure how many U's each device is. So all of these look relatively thin and small. They're probably all 1U. And you can stack them up and see how many that you can get inside your rack. And then there's cabling and different power provided. So these are called power distribution units, or power racks, some people call them. And they can be on the side, or they can be mounted up and down behind the equipment usually. Okay, now let's talk about patch panels. A patch panel is just a box with female ports in the front. They tend to be more permanent connections in the back that are just wired and set, and we don't change them out too often. But we do change the cables that run from them, or we move them over to different patch panels that we need to, and kind of segment our network and divide it how we need to. So these are both essentially the same thing. These are the female ports, those are just patch panels. Here we have what's called a punch down tool. So you can punch down onto what's called this block here, and you can wire a connection to the back of a patch panel that way. Here is a typical 66 block for a telecommunications room. They're slowly going away, but you'll still see some in larger buildings or ones that use legacy telephone equipment for whatever reason. Okay, and here's another example of a patch panel, but it's managed quite well with different labeling and different letters, so you can see where it's going to on the map or on the wire map, and you can figure out the floor plan. Okay, so this patch panel in particular is Cat 6 grade. It's important to know what the minimum grade is for each cable, because you will need to have throughput for each bandwidth going through the patch panel, and if it's equal, then your quality of service won't be disrupted and you will get good throughput and bandwidth for each cable. Okay, so we were talking about punch downs before. So this is what a punch down looks like on a 110 punch down block. Some people call it a BIX block on the wall, this one. But different technologies. This one's called a chrome block. It's a 110 punch down block. So that's the back end to the patch panel. Okay, so here we have a rack. Rack 1, rack 2. We talked about racks. We build up and then we run our wires vertically over the wall through the ceiling. This is pretty ideal and typical for most cable runs. And here's what the end result would look like. You would see some cable coming from the wall and then going out into a telephone or going out into a computer. It's important to label which patch panel is going to which office so you're able to troubleshoot and diagnose issues with either that cable or that run. Okay. Earlier I was talking about 25 pair and 100 pair cables. Here's an example of a 25 pair cable punched down onto a legacy 66 block. So you'll find those in different telecom rooms like that. But nowadays it's quite common to find different equipment like a cable modem, an optical network terminal, or any kind of NIU or network interface unit that's supplied by your ISP. So this looks like an optical unit for fiber. Okay. Here's a DMARC room or a mid-sized telecoms room with all of the equipment we just spoke about. This looks like the punch down over here. I think that NIU is one of these. So it's a little bit messy, but we're able to figure out what's going on. Okay, here is a punch down for fiber, which isn't something I've really seen a whole lot. Maybe an ISP would have more hands-on experience for this, but routing all the different fiber connections horizontally, going up and down, and going out to the different optical terminals or the different customers. Here's an example of a cable run that's going to be used in this map. It tells you exactly where to drill so you can get the cables through the wall. And once it's through the wall, you'll run it and follow the dotted line and see how many cables you need to run through the wall and get it through. This can cause all kinds of challenges physically. You're going to need probably multiple people to help you do these things. And this one doesn't look as nice as a real drop in the wall, but it gets the job done in case you need to run some cables instead of, I guess, over, it would be under you, but it's still vertical, right? Okay. All right, in these rooms, this equipment is very sensitive. We need to monitor everything to make sure that humidity is fine, temperature, those kinds of things. So we can monitor in the telecom room with monitoring software. Okay, here's another example of a cable run, but it's using a tray. So instead of drilling holes in the wall and crawling around, you can just run a tray over your head and over some equipment, and that way you can carefully see what kind of cables are being run this way and this way. So a bit more work, but in an industrial setting, that would be ideal. Here's an example of what you don't do with cable trays. This cable tray is a mess. If I need to pull a cable or if one's broken and I need to figure it out, it's going to take me a long time and I'm going to have to pull a bunch of cables and see which one wiggles and moves, and that's going to be a headache. However, look how clean this one is. It's very tidy and organized. You can see the color scheme is separated and one, two, three, four different types of blue cables. So it'll probably be a lot easier to diagnose if there's a problem, or knowing which one goes to this network segment or this VLAN or this subnet or whatever. Okay, so running cable and making a cable drop is not easy work. It takes a lot of physical labor and usually multiple people. Okay, so you would have to cut a hole in the wall, like a square. You would have to get a wire through the wall. Look at this pin, this screw that's used, and they pull the wire through, and that way they know that it's a good drop and you can push the cable through later. Okay, they put the faceplate on, and looks like this blue cable that we were talking about earlier is running to this office here. So this is the beginning result and this is the end result of what it would look like. Let's talk more about crimping the cable and preparing the jack. Okay, so here's a cable crimper and stripper. The bottom strips the cable. So this is a stripped cable with plenty of room in case there's a mistake. Then you can, cut it again and make sure, but always have a little bit room for air. Okay, so we push down the crimp on it. We line up all of the lines to make sure it's correct to get the type of cable you need. You don't want a crossover cable, right? Okay, then you crimp it down and your end result will look like this. We probably want to put a boot or a shield over it to make sure that it's durable. Okay, talking about cable management again, here's two examples of a nightmare versus one that's quite nice. So if you needed to diagnose a problem with a network cable here, it would be a headache, but over here, probably a lot easier on your eyes and visually just easier to digest. There's a lot of different tools we need when installing a physical network. Copper breaks, it's much easier to detect with a continuity tester like this one. So we can tell when there's breakage. Case scanners can find problems and wire map. Multimeters can read ohms. So if you have 0 ohms, that means there's good continuity. But if there's infinite ohms, it means there's no connection. So all of these three tools are quite important. Okay, time domain reflectometers. Some can tell you the length of a cable or where it's located and where it broke. So this takes a lot of guesswork out of it, but obviously these devices are much more expensive. Okay, let's talk about crosstalk. We are talking about cables breaking and diagnosing. Crosstalk is naturally going to be the topic next. So crosstalk occurs when there is interference, electrical magnetic interference between two cables because they're not shielded. So this electrical signal that they send creates some sort of problem with the signal. Okay, let's look at a real world example. On the left, we can see near-ended crosstalk interference. So this signal could give off other electrical magnetic interferences to other cables around it. That's called near-ended. Okay, let's talk about far-ended. So if we put a cable tester on each end, listening on 1 and 2, listening on 3 and 6, we can see here that there's some crosstalk going to this particular cable here. So that's far-ended. On the other end versus being near-ended, which is happening close to you. Okay, installing fiber or dealing with fiber, because we just talked about copper. Yeah, fiber can have signal loss from light leakage. Here's an example of the light changing color. It's like white and then it's green. So you can see that there is signal loss here when it bends too much. A lot of technicians need to cut fiber or splice it on the field. So you'll have a field bag with all kinds of tools to cut and splice and get the cable back up again. And here's an optical time domain reflector, which is used for optical networks, but does the same thing. Okay, let's talk about different kinds of NICs. Here's a typical NIC that you see on a desktop. And here's one that we would use for fiber. Here's a NIC through USB-C. This is more common today on mobile devices and laptops. Okay, so different ports and aggregation. That's the next part of the chapter. So if we look at these ports, we can see that some are turned on and some are turned off, some are green, some are being used at the same time. This is called link aggregation. So the link aggregation control protocol controls how multiple network devices send and receive data. Okay, when troubleshooting a network interface card, one of the first things you want to do is actually go on the computer and see, is there a connection? Is it connected to the network or not? Is there a world like a globe? That means there's no connection. Or is there a wire in a computer monitor, which usually means you have a connection? You can test physically if the NIC is working by using a loopback. That will let you know if the link lights come on and if they're functioning. Okay, and we're on the last slide here. Here's an example of a loopback adapter in action. So we can actually see if this loop device is working correctly. We can use a scanner to send a signal, and if it comes back, then we know it's good. If it doesn't, then we can further isolate, is it the cable, is it the loopback, or keep going. Okay, here's an example of a voltage reader. You can see how many volts are being used in this telecom room or this rack area. So you want to be very careful you're not using too much. Okay, and we did talk about a lot of equipment, but this book really likes to talk about Fox and Hound. These are probe and tone generators, probably the best that money can buy. They look very nice. Okay, so let's go to the pop quiz. How many pairs in a cable were old telephone room 66 blocks? Yeah, so what kind of cable did those blocks use? Number 2, how did we measure equipment in a rack? Number 3, what is a cable raceway? Okay, are you ready? Let's go. Earlier we looked at a picture of a 25 pair, and even some telecom rooms used 100 pair, I guess in a larger environment, to connect legacy telephones. I thought that was pretty cool. I didn't know that. Okay, how do we measure equipment in a rack? Do you remember? So we do need to know how big or small some equipment are. We call them U's or units. So we measure them in a unit. So this is 1 unit, 1 unit, 1 unit. So if a device takes 5 units, then you know how big it is. It's probably too big for this. And what is a cable raceway? Well, we talked about cable drops and running cables, very difficult job, but one way that we can easily accomplish this, at least in the short term, is to use a cable raceway to have a cable run on the wall and give you different jacks so you can connect to internet. Thank you for watching.